Hello students, welcome back to our science video. For today's lesson, our topic is about the law of conservation of momentum. At the end of this video, learners are expected to infer that the total momentum before and after collision are equal, and solve word problems involving law of conservation of momentum. Law of conservation of momentum. When two objects in an isolated system collide, the total momentum of the objects before the collision is equal to the total momentum of the objects after the collision. In the given example, momentum of object 1 is equal to 10 kg per second, while object 2 is 0 since the object is not moving. As the object 1 hit the second object, the momentum lost by object 1 would be equal to the momentum gained by object 2. Newton's third law of motion is applied in momentum conservation. It is also known as the law of action and reaction, tells that if object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. This law represents a certain symmetry in nature. Forces always occur in pairs, and one body cannot exert a force on another without experiencing a force itself. Just like in billiards, the amount of force exerted by the cue ball causes the target ball to move with the same amount of force but in opposite direction. When the cue ball hits the target ball, momentum is transferred. The momentum gained by the target ball is just equal to the momentum lost by the cue ball during collision. In other words, no momentum is gained or lost in the system. In all forms of collisions, momentum is conserved, whether the collision is elastic or inelastic. Momentum does not change before and after collision. Mathematically, the law can be written as momentum before is equal to momentum after. P before is the momentum before collision, while P after is the momentum after collision. It may expanded considering the system's total momentum, by just having sum of the first and second initial momentum is equal to the sum of first and second final momentum. 1 and 2 indicate the momentum of the first and second objects, while I and F indicate initial and final momentum of the objects. But if there are two objects in collision, the equation can be expanded as m1v1i plus m2v2i is equal to m1v1f plus m2v2f, where m sub 1 is the mass of the first object, m sub 2 is the mass of the second object, v1i is the velocity of the first object before collision, v2i is the velocity of the second object before collision, v1f is the velocity of the first object after collision, and v2f is the velocity of the second object after collision. To apply those equations, let's answer some sample problems. Two cars collided head-on. If the total momentum of the system before collision is 150 kg per second, what is the total momentum after collision? To answer the sample problem, let's follow these steps. Step 1. Identify what is required to find in the problem. You are asked to calculate for the total momentum after collision. Step 2. Identify the given in the problem. The initial total momentum of the system is given, which is momentum before is equal to 150 kg per second. Step 3. Write the working equation. We can use the formula momentum before is equal to momentum after. As we substitute the given values, we have momentum after is equal to 150 kg per second, wherein our final answer will be momentum after is equal to 150 kg per second. Let's have another sample problem. Two toy cars have initial momentum of 100 kg per second and 150 kg per second before collision. If the second toy car has 120 kg per second momentum after collision, what is the momentum of the first toy car after collision? To answer our second sample problem, let's follow these steps. Step 1. Identify what is required to find in the problem. You are asked to calculate the final momentum of the first toy car. Identify the given in the problem. The initial momentum of both toy cars and the final momentum of the second toy car are given. Step 3. Write the working equation. The sum of the first and second initial momentum is equal to the sum of first and second final momentum. To get the formula of our desired quantity, we need to transfer the second final momentum on the other side of the equation, wherein it will become first final momentum is equal to the sum of the first and second initial momentum minus second final momentum. As we substitute the given values, first final momentum is equal to 100 kg per second plus 150 kg per second minus 120 kg per second. So the final answer will be first final momentum is equal to 130 kg per second. For our last sample problem, a car with a 100 kg mass moving at a velocity of 10 m per second to the right collides with a car with the same mass moving at 40 m per second to the left. What is the velocity of the second car if the velocity of the first car after the collision is 15 m per second to the left? To answer our last sample problem, let's follow these steps. Step 1. Identify what is required to find in the problem. You are asked to calculate the velocity of the second car after a collision. Step 2. Identify the given in the problem. The mass of the two cars, velocity of the cars before collision, and the velocity of the first car after collision are given, wherein mass 1 and 2 are both equal to 100 kg. First initial velocity is equal to 10 m per second. Second initial velocity is equal to negative 40 meters per second. And first final velocity is equal to negative 15 meters per second. Step 3 is to write the working equation. In the general formula, m1v1 initial plus m2v2 initial is equal to m1v1 final plus m2v2 final. We can derive the formula for the second final velocity, which is second final velocity is equal to first initial velocity plus second initial velocity minus first final velocity. Step 4. Substitute the given values. Second final velocity is equal to 10 m per second plus negative 40 m per second minus negative 15 m per second. In performing the equation, the final answer will be second final velocity is equal to negative 15 m per second, or the velocity of the second car is 15 m per second to the left. Always remember that the momentum of a system is always conserved for all types of collisions. And the law of conservation of momentum states that when two objects in an isolated system collides, the total momentum of the objects before the collision is equal to the total momentum of the objects after the collision. Thank you for watching. Do not forget to subscribe for more science educational videos by clicking the notification bell.